This video is about the transformations of trigonometric graphs. We will see four main function transformations at work, and function transformations that are very similar to transformations that we have seen on other functions, not just trigonometric functions. We'll start with the base function y equals sine of x, and one by one apply the different transformations. First, our a transformation, as I call it, is some constant multiplied to the function. If you remember transformations from earlier, this a transformation, a constant multiplied out front, executes some sort of vertical stretch or compress. Let's go right to some examples. Here is y equals sine of x, and now let's make an a transformation. Let's look at the graph of 2 times sine of x. And we do see that our graph has been vertically stretched by a factor of 2, where we had peaks at 1 and -1. Now we see them at +2, a peak at +2, a valley at -2. So each function value has now been multiplied by 2, and the result is stretching it by a factor of 2. We'll see it if we look at 3 times sine of x. Everything has been vertically stretched by a factor of 3. The positives have become more positive, the negative values have become more negative. Multiplying by a factor that is greater than 1 accomplishes this stretching, and if we multiplied by a factor that was between 0 and 1, we would see a vertical compress. We are multiplying by 0.4, so every function value is now 4/10 of what it originally was in the sine function, and the result is a graph that has been compressed. If we were to multiply by a negative number, the result will be, just like it was before, a reflection about the x-axis. Now with trig functions, it's difficult to see exactly what caused the change that we see right here. It is actually the same change as if we reflected about the y-axis, or if we reflect about the x-axis, it looks identical. It even looks identical to if we just shifted our graph one way by 180 degrees or opposite way by 180 degrees. So a few different transformations can all lead to the same effect. We'll explore those in more detail later on when we talk about some identities and even and odd functions, but for now, I want to point out that multiplying by a negative out front accomplishes a reflection about the x-axis as it has done with function transformations up to this point. If we multiply by a negative number, but not -1, we will see both of those changes. We will see a reflection about the x-axis, and we will see a stretch or compress. In this case, multiplying by -2.5, we have our reflection, and then vertically stretching by a factor of 2.5. When we're talking about trig functions specifically, we call that value of a the amplitude. On the graph, the amplitude is the distance from our midline to a peak or to a valley. The sine function goes between -1 and +1, but the amplitude is not a measure of that total difference, which would be a total difference of 2. It's actually half of that total difference. So a couple ways to look at it. One way would be look at our max to min, the complete range, which would be a total distance of 2, and then cut it in half is one way to find amplitude. Or the other way is that we just start off right at our midline and see how far it would be to go up to a peak or down to a valley. So sine, we know this is multiplied by 1, the amplitude is 1, and in our green graph, now we have an amplitude of 3, and we see that we are multiplying by a factor of 3.